Right, so today I'm going to focus on the work my team at Grounded AI did with Wikimedia Enterprise. Is this mic? Sounds like it's going on and off, okay. As a real-world example of applied AI in business. So my goal is to use this case study to explore some of the common questions and challenges that we encounter during applied AI projects. And by the end of the talk, I hope you'll have gained some insights into how AI is being used in the wild, and hopefully that will translate to confidence about using AI in your own ventures. So what are some of the common questions that we encounter during applied AI projects? Let's say you've identified an area of your business you want to optimize or a problem you want to solve. In the first case, is your problem a good use case for machine learning or AI? If it is, then how would a solution fit alongside your existing systems? How could you evaluate and trust an AI-based system in your specific context? Should you develop custom models, use off-the-shelf models or commercial APIs? What are the steps to deployment and productionization? And how much will it all cost? So let's look at our case study to illustrate these challenges in context. So I'll assume everyone's familiar with Wikipedia, one of the most comprehensive and well-curated sources of knowledge in our world. Wikipedia sits alongside various sister projects under the umbrella organization of Wikimedia. And Wikimedia has a commercial arm, Wikimedia Enterprise, which generates revenue by providing API access to structured data from the Wikipedia knowledge base. And this API is used by tech firms, think Google, Netflix, Amazon, Apple, Meta, to power features like search, question answering, and recommendation in their products. So Wikimedia reports several million in revenue from this API offering, and the motivation here is to develop this proposition and expand the revenue stream. So the problem that Wikimedia faces here is that Wikipedia is heavily unstructured, with diverse authorship across many different domains and languages, resulting in a complex landscape of different formats in which information is presented. So the goal is to extract key information from Wikipedia pages and convert them to a highly consistent and standardized format for the Wikimedia API offering. And the value of this is to provide a clean, machine-readable representation of the knowledge in Wikipedia that can be readily used in the databases and products of its customers. So how can we solve this task? Well, clearly, we want to automate it. So we're left with two serious alternatives. We could build a rule-based system, which involves a large set of handcrafted rules written in code, or we could use an AI-based system, which leverages statistics to handle the complex variety of patterns and create the outputs that we want. Slide malfunction. Brief interlude. Could have chosen a better screensaver. Everything goes fine in the tech rehearsal. Pressure's on to put the password in correctly. Just like, oh, damn. Great. So, we could use an AI-based system, which leverages statistics and handling all the patterns and creating the outputs we want using that inbuilt statistical knowledge. So, let's consider the trade-offs here. A rule-based system has all the properties of a traditional software system. It's an explicit set of decisions written and maintained by humans. The problem with this approach is the sheer scale and complexity of the task. A code base with enough rules to handle all possible cases would quickly become unmanageable, and it cannot dynamically adapt to new patterns that emerge with time. And this is where an AI-based system has great promise. It can handle the otherwise intractable number of variations we would need to solve, and the availability of pre-trained large language models provides a solution that we might be able to leverage immediately here. And a note on why large language models specifically are promising here is that due to their broad training, they have a good general knowledge about how information is usually arranged. They have a strong learned association between different ways of expressing the same concept, so they know that date of birth is the same thing as birth date. And they have great multilingual capabilities out of the box. And these are all features that we could use as we progress here. Now, these systems bring the downsides of black boxes, such as a lack of interpretability and control. They do pose a new set of operational challenges, and depending on the sizes of the model, can be computationally expensive to run. But on balance, an AI-based solution is very attractive for this type of problem, and Wikimedia realized this and contacted us. So we initiated an exploratory project to test the ability of large language models for extracting and reshaping information from Wikipedia. And due to the availability of pre-trained large language models, we were able to quickly implement a POC to show that this does work in principle. So we take this messy, highly variable HTML input, and the output we generate is a clean and consistent JSON format that contains only the information we care about. It's worth noting at this point that while we're focusing on Wikipedia data here, the techniques we're discussing are broadly applicable. So, for example, in medical and pharmaceutical domains that we work in, we often face this same challenge of extracting information, converting it to a more useful, convenient format to unlock the utility of that data. So, how do we get a broader, more quantifiable understanding of the performance here? Now, ideally, we compare our system to a set of gold standard human-curated data, but as is often the case, this was not available here. So we developed a set of automated checks to validate the data structure and content. For example, one of the popular concerns with large language models is hallucination or fabrication of information. So we developed an approach to trace information from the output back to the input with a measurable confidence. And this allowed us to flag problematic examples automatically and use this as a starting point for manual correction. Correcting examples is much cheaper than generating examples from scratch. So this is an example of how to bootstrap the evaluation process in the absence of human-curated data using automated signals. It's worth noting at this point the size of the data set. So Wikipedia contains almost 60 million pages across over 300 languages. So this is a large space. So the next thing we did is to scale up the analysis and run it over a broad representative sample, taking into account the full diversity of examples and outliers. And this allowed us to get global metrics about how it performs. So what we found was that we could verify about 90% of the information that the large language model generated. Now for Wikimedia, it was much more important to be correct than complete. So for the remaining 10% of information that we couldn't verify, this could be automatically excluded from the output. So we only produce an output that contains information that we are highly confident about. In terms of productionization, we considered two major alternatives. We can either rely on commercial APIs, using models similar to those powering ChatGPT, or we can build and manage custom models. So in this case, we compared the use of the OpenAI API to the case of fine-tuning smaller models for self-hosting. And we found the latter to be significantly more cost-effective and faster for large-scale implementation. Now, going the custom model route also gives you an asset you control, which reduces the risk of someone else turning off the service or subtly altering its behavior over time, which does happen. There are also broader business cases to consider. If you own the model, you can apply it and monetize it in other areas. So these are all factors to take into consideration here. As a result of this work, Wikimedia advanced their position in understanding how and where they can apply these technologies. And in particular, they told us that they valued the pace of the work, the research documentation and demonstrations that we provided, and that the productionization assistance was key. But the answers to the questions and challenges I've outlined all depend on your unique situation. And what Wikimedia did here was to invest in learning with this pilot study. So if you see an opportunity in your space for data transformation technologies or AI more generally, I recommend you invest in learning, ideally with a fast-paced pilot study. And there are lots of people here who can help you do that. I invite you to seek them out and discuss your ideas with them. That's it from me.
Thank you very much, Nick. So Catherine Breslin is our next speaker. Catherine previously studied voice technology and human-computer dialogue at Cambridge University, and she went on to lead Cambridge's Amazon Alexa team. She now freelances with artificial intelligence startups specializing in voice technology. It's Catherine Breslin.
Thanks, Mark, for the introduction. So I think Nick laid out some of the real challenges that everybody has with AI systems. And so today I decided to focus on one particular project that I did with a client of mine last year and the year before. And this is about AI-powered video navigation for the legal sector. So I should say that this is not a solo effort, this is a team effort, as all machine learning projects are. So this was a project done in collaboration with the University of Surrey, so Hadil and Konstantin there, me at Kingfisher Labs, and then Vinay and Sophie at Just Access. Just Access are a legal startup, and Sophie Walker is the founder and CEO of Just Access, and she is really the driving force behind this project, which ended up being funded by an Innovate UK Smart Grant. So this is the UK Supreme Court. The UK Supreme Court hears court cases, and what you can see in this picture is 5 justices sitting around the top table, listening to arguments from 2 sides of a single case. This is not a jury trial, this is a civil case, and this conversation is recorded. So a lot of our courtroom data is recorded, and that data is then stored and can be used. But court cases are long. If you look at how long a court case might be, if you go into the lower courts, it can last for days, weeks, months. In the Supreme Court, they typically last somewhere between a few days and a week or so. So all in all, you've got hours and hours of audio recording of people discussing a case. The outcome of the case is, I think we have a slightly older version of my slides here because I updated them today, but let me show you here. What you have on this picture here is a snippet of a court judgment. So after a court case has been heard, the judge will write a judgment. And that judgment can be quite long, it can be pages long, and it's some quite dense text with lots of legal terminology in. But it justifies the judgment that the judge came to. And of course, that judgment links up with the conversation that happened in the courtroom. And legal researchers and law students, when they come to look at judgments, really want to understand why a particular point arose in the court case, why the judgment was made, what relevance it has. But they have to go on the judgment text because they don't necessarily have access to the court audio hearing recording. And even if they did, it would be hours long and quite difficult for them to sift through in all the court cases they were interested in. So this is our task, is to try and provide a tool where we could link up the text in the judgment with the audio in the court case so that would speed the job of legal researchers in preparing for cases. So we had 2 challenges in developing this product. So I wanted to focus on the 2 data challenges that we had. This was a long project, it was an 18-month project, but it's really the data challenges that I think are interesting and quite representative of some of the challenges that people face in AI. Hang on, the text on this has gone. So there should be some text on here. There isn't. I think it's right at the bottom here somehow. So let me see if I can remember what I put on my slides. So our first challenge was accessing data. So there is a big difference between recording a court hearing and making it publicly accessible on the web. And nobody wants us to put all of our court hearing data on the web. And the court hearing data is owned by either the Supreme Court or the HTCMS, I think, the people who run the court hearings. And so you have to apply to them for access to audio recordings of court data. But, and the reason we use the Supreme Court is that there does exist a set of cases on the National Archives website, which is available under an open government license. It's a set of video recordings of Supreme Court cases from, I think, 2010 and 2011. So we used those as our proof of concept in building this model out. The second challenge we had was accessing the judgment data itself, the text, the result, the outcome of the court case. And that, all of the judgments in the UK are available on a website, but it's under a license called the Open Justice License, which doesn't allow for computational processing of the text. And so you have to put in a separate application to the National Archives in order to be able to access the text of the judgments in order to be able to do this data processing. So the first challenge we had was this fragmented data landscape that we've got in the legal domain. And I think this is quite common in a lot of places, that you are pulling data sources from different places, trying to link them together in order to build what you want. And our second challenge in all of this was annotating the data. So we wanted to show that our method was going to work, that it was going to come up with good links between the written text and what people had said in the courtroom. Now this is a task which is actually really challenging for people to do. Like, I've looked at some of those judgments. I couldn't tell you which bit of the judgment led to which bit of the court case. It's beyond my knowledge of the law. So we need expert annotators to do this. And in particular, we used annotators who were law students studying their second degrees. So people who had already got some sort of undergraduate degree in law, were doing some work on the side. So highly expert annotation task. Unlike some of the other annotation tasks that you might have heard of that are sort of outsourced to large companies, this one was very, very expert. And we needed people who understood the law, understood court cases to be able to do it. And the second problem we had with annotating the data is that none of the data annotation tools that exist online are really designed for this particular use case. So they're designed for labeling short snippets of text, and they didn't really work with this sort of judgment and video combination that we had. So what we ended up doing was building our own annotation tool here. This is a little screenshot of what we built. I say we, I mean Konstantin at Surrey. It shows the annotator a little snippet from the judgment on this side, and then it shows them the video and a little snippet from the video, and it asks them the question, are these two linked? And so in order to answer this question, our law student has to go and look at the case and listen to the video and make a judgment about whether they're linked or not. And we had to show them not only examples that we thought were linked, but also we wanted negative examples in there. So you can think about this a little bit like if you put a search into Google, you can't obviously go and annotate the whole of the web to see whether it matches that Google search. And we're in a similar scenario here where we've got such a lot of possible links, we can't go and annotate them all. We had to be very careful about choosing which ones we could. So there was some work here to sort of sift through the data and figure out how much of it we could annotate in order to get useful numbers. And luckily this worked, which was very good. We found, actually, I forgot to say, or I didn't say, at the very beginning of the project, before I started working with it, there was a very smart law student who was doing this by herself with no help from technology. She was super smart. And it took her 15 hours, I think, to listen to all the audio, read the judgments, and get as far as annotating 10 links between the audio and the text. And once we've managed to use our NLP-enabled matching to automatically identify links between the two, we found that it took 3 hours for our annotators now to identify 220 links. So a huge jump in performance and how much data we could handle. And this takes it from something which I think is unfeasible as a product to something which is still quite pricey, but is starting to look much more feasible to build as a product. And so this is actually a screenshot of the product as it exists right now. So this is what your legal researcher might be able to look at, whereby they can take the court case that they're interested in, they can click on the bit of the judgment that they're interested in, and it can start to show them over on the other side the bits of the video that are directly linked to that part of the judgment. And we hope that this is going to speed up the work of legal researchers and really allow them access to the video that they didn't have before. So this, I didn't talk about the modeling that we used under the hood to do this. We're using NLP techniques to do the linking up here, and I don't think that's hugely relevant to the points I'm making about data. And so some of the difficulties of accessing data, some of the difficulties of annotating data that we see in some new applications of AI that are coming out. And this does work as far as we see, and we're taking it out to show to potential customers right now. So thank you very much for listening.
Thank you very much, Catherine. Alex Housley is joining us. Alex has been founding and building technology companies since 2003, specializing in mobile, data, and machine learning. Alex founded Selden back in 2014 with the aim of democratizing ML operations to solve the world's most pressing issues. He was CEO until 2023, shaping the MLOps industry and delivering measurable, meaningful results for clients worldwide. As Chief Product and Technology Officer, Alex is responsible for the product and technology strategy and execution. So Alex joins us here. Thank you.
Great, thank you, Mark. Thank you, everyone. So I'm going to talk a bit about MLOps and the challenges of running ML at very large scale in production. So our mission at Selden is to accelerate the adoption of machine learning. I'm sure you're all thinking, why does AI need accelerating? It's like a runaway train. And for the last 5-6 years, 5 or 6 years ago, we were all talking about like all of our jobs being replaced, within the next few years, and us all been on universal basic income by now. But that's not the case, actually. About 80% of AI projects are still failing. So it still needs, this mission is as relevant today as it has ever been. So a good place for us to start really is the market thesis for ML infrastructure. So very broadly, we see there being two sides to the ML market. On one side, you've got model deployment and model development, and on the other side, you've got model deployment, which is where we sit. So on the development side, main stakeholder now, we'll actually just call them a model developer, because previously they were a data scientist. Now there's a much broader range of stakeholders who are now involved in creating models which are used within organizations. So data citizens have been around for a few years. Now there's a very broad range of prompt engineers. I think pretty much everyone in this room has been prompt engineering in some form. So these engineers, we call them like model developers, they want choice. So they want to use the tools that are most effective for the problems, the use case, the modalities of data. And but when you flip over to the deployment side, the main stakeholder, we can call them an ops person. By this I mean like ML engineers, DevOps, stakeholders who really care about the performance of the models in production. And this can include also, of course, the business stakeholders who are sponsoring the project, and people now relating to, with roles covering governance, risk, compliance. So these stakeholders want control. Okay, so really it's about balancing these two sets of priorities within organizations, within your ML systems. And outside of that, there's a broad range of stakeholders who are engaging with your ML systems, both internally and externally. So it's important that as you're building out systems, you have to look at it through like a multi-persona lens. And whenever there's effectively a handover from one of these stakeholders to another, you have sort of friction within that process, which you need to sort of reduce those handshakes, reduce the time it takes for those handshakes. So a few stats. We've been working very closely with companies in regulated industries, primarily around FSI, but quite a few in life sciences as well, with various drug discovery pipelines. Yeah, it's clear that like as it stands, like Gen AI is obviously here to stay, and it's a huge mega trend. Most of the regulated industries now are adopting Gen AI and LLMs, and we've even, through speaking directly to some of the world's largest banks, folks who are responsible for the infrastructure there are saying that a whole new category of stakeholder are literally coming to them, and I quote, with bats, to knock down the door to get access to these Gen AI algorithms, so Gen AI models. And so why do we want MLOps? Why do we care about it? So first off, it's there to help organizations to maximize the business value. So accelerating the time it takes to deploy models from months to minutes. There's a huge opportunity cost there. ensuring they can scale to the very large volumes that enterprises need. The carbon footprint of machine learning has never been a bigger topic, especially with the huge LLMs that are being trained now, costing tens of millions of dollars. And actually, if you're looking at the 350,000 H100 GPU order that Mark Zuckerberg just put in, we're looking at billions of dollars that will be utilized on training models. The Falcon 180 parameter model alone took 4,000 GPUs, and that was simultaneously 7 million GPU hours to train. But when you look at the amount of cost that is associated with inference, which is actually running models, compared to training models in some of the most sophisticated AI organizations, such as Meta, actually about 90% of their costs are actually associated with inference, so not with the training side. So ensuring that the carbon footprint and the efficiency with which you're deploying models is really critical and often overlooked. Then, of course, we've got like the managing the risks associated with ML. A lot of that is covered by ensuring that the models do what they say they will, and they're reliable. But then also meeting the current and upcoming regulations. So I'll give you an example of some of the things that we've been implementing to help organizations to solve these problems. So the first piece here is around developing data-centric pipelines. So thinking about deploying not just a single model, but in effect a pipeline which has multiple components, and that includes data flows and models. Within that, you have certain workflows which are synchronous, and some of them like sort of batch processing, for example. Some which are asynchronous, like you may want to have some like monitoring alert that pops up when, say, the model is drifting. Okay, do a quick switcheroo. So I won't go into all the details here. The second piece around the optimization of energy consumption. When models are deployed, generally what happens is there's a little bit of kind of overhead in the server which isn't utilized. So when you start to like deploy multiple models at a larger scale, that soon stacks up and you have a lot of wasted compute. And then when organizations want to scale their models, if they don't have a way of managing the spikes in traffic and consumption, then they may, as a sort of to mitigate that, they may over provision the amount of resources that they need. So a combination of cloud native technologies, as well as the ability to overcommit. So to have like intelligent caching so that you can pull certain models that are not as heavily utilized to disk, so that they're not tying up the GPU. So this is an example of the type of cost saving. Obviously, just from a conceptual view, as you scale, it's a very significant opportunity. So on the explainability piece, this is obviously tied to a lot of significant regulatory requirements, and we're finding that organizations require explanations in order to satisfy the sort of transparency and feedback to regulators on why they made certain algorithmic decisions. And in certain cases, the companies in regulated industries are sort of working ahead of the regulatory requirements so that they're prepared for that in future. So an example which we'll get to in case studies that is one of our customers called Kaveh Insurance that handle a huge amount of insurance claims. Shall I go back? Go to that one first. They handle a huge amount of insurance claims, which have a significant overhead on their claims team, and they reduce that sort of manual process and workload by integrating a variety of sort of NLP and computer vision classifying models across the various different types of insurance, but then they have the explainability that they can report back to regulators and drift detection to ensure the models are working optimally. So they achieved about an 11x ROI in 6 months by implementing MLOps best practices. And a couple of other quick examples here of other companies that we've been working with. In the materials sector, there's a very large global mining company. They've implemented like classifiers into, or computer vision and classification into the output of the sort of mining like systems, so that they can sort of associate an appropriate cost much earlier in that sort of production workflow. And then just to briefly touch upon the others, I'm sure you can see it here. Some like use cases around defense. I can't go into like obviously like all of these. A lot of our use cases actually are sort of developed internally by our customers rather and deployed on their own systems as well. But obviously with predictive maintenance use cases, when things go wrong with helicopters, and they go very badly wrong. And in the automotive space, we have a few large customers. Ford is one of the bigger ones, and they have a F100 rolling off the production line every 52 seconds, and there's crack detection and a full 360-degree scan of each truck as it's rolling off the production line to check that all the parts are fully aligned and working optimally, taking into consideration the different environmental factors in each of their different production lines as well. So I'll stop there, but we'll hand over for the next step. Cheers, Mark.
Thanks very much, Alex. Finally, we have Tim Gordon. Sorry, I have to just put my notes down. So Tim is a co-founding partner at Best Practice AI and Salus AI. Best Practice provides strategy advice to startups, corporates, and investors on how to use AI to build sustainable competitive advantages. He's also a trustee at Full Fact, where he shares their automated fact-checking work. So, Tim Gordon.
Thank you. And it just says great to be on stage after Alex. I think he's built one of the most impressive UK AI firms in London, so it's really great to be here with him. Look, hands up, I'm probably the least technical person in the room. So I'm here to talk a bit more about some of the operational aspects around the humans who are part of AI, and really thinking a bit more about some of the incentives in terms of the people you'll be interacting with as you try and roll projects out to see what works and what doesn't work. Now, we'll get to this in a sec. Okay, so bringing AI to life. So I'm going to start talking a little bit about myself to give you some sense as to why I'm a person to talk about this. In the 1990s, I started my career in the newspaper industry. And the newspaper industry was then destroyed by the first wave of the internet, and hundreds of people lost their jobs. I then moved on to the yellow page industry, which in the 2000s was destroyed by Google, and hundreds of people lost their jobs. I then worked in politics in the 2010s, and social media came along and smashed up pretty much everything we know about that industry. So my entire career basically is the race between bringing tech on board and persuading managers to bring tech on board and being toast. And I'm now a consultant, and ChatGPT's come along, so let's guess what's going to happen to my industry in the near future. I want to talk about two projects we've worked on, and these are slightly old now, so they're not using the latest generative AI technology, but two projects we worked on in US healthcare. And the first one on the left is basically a synthetic image generation product we worked on. And this was a situation where if you are a orthopedic surgeon in the US, you have a vast amounts of tools you bring to the game. You have a huge array of very delicate cutting tools. You have all sorts of very specialist things you insert in people's bodies. These things are very expensive. They can cost hundreds of dollars or even thousands of dollars to put these things in people's places. And they're scattered all across the US. There are hundreds of thousands of places where this surgery happens. And one of the key challenges here is how do you keep track of all the inventory? This is expensive stuff, it's expensive metal. So how do you keep track of the inventory that's out there? How do you make sure people know what's going on? And that's important for the suppliers, it's important for the individual doctors, and theoretically at least, it's important for the hospitals, because if you're buying a tray full of kit that then disappears or you lose pieces, there's a lot of money that's hanging around, both in terms of your cash flow management, but more importantly, actually, in terms of cost. And so one of the things we try to do here is to build a tool, or the teams we work with, to build a tool that would basically use computer vision to work out and keep track of where those various pieces of kit were, where the various tools were, and above all, some of these trays. These trays will actually cost thousands of dollars, which have got all the various bits of kit in them. And trying to capture, using image generation, photos of all these things, such that you can build an image, a tool to recognize this, was incredibly hard, because how many pictures do you have to take to capture something that works in different lights, in different sort of situations, with different things, pieces obscuring each other, with a whole series of different ways in which the pictures work. So we went out there, and what we did here was we effectively took tens of pictures of the various tools, built 3D models of them, and then effectively generated thousands of synthetic pictures that we could use in all these different scenarios with different colors of lights and so on and so forth. So this was a project that basically was highly technically proficient, drove things at the edge in terms of what we're doing with the technology. We got a patent for this particular project, so it's something that really drove the edge. So that's one project. The second project I want to talk about in the US medical space is a far simpler one, which essentially was trying to work out which salespeople were doing dodgy things. Now, in the US healthcare, you may be surprised to hear there's quite a lot of dodgy things going on with US healthcare calls. And what we tried to do there was something that's actually far simpler, which is we worked out basically how to do a sort of use AI for the transcription of the calls, and then a pretty simple rules-based model to work out where people were doing inappropriate things. Now, the technology there was all out of a box. We pretty much used various suppliers, often focused as much on price as anything else. Which of those two projects do you think actually got the cut through? The clue is probably in the answer. Which one? Precisely. It's the fast and simple one. The highly sophisticated tech one posed a problem that doctors cared about. A huge amount of the angel funding came from doctors who'd had this problem. US doctors make lots of money, they're retired, they like funding various projects, so people were keen to fund this. So we really thought this is a project that's going to work. The doctors really care about this. They're prepared to put their money in the pot to make this happen. This must really work. But the issue around this is the incentives. And the incentives are far more complicated than we expect. Because it turns out that to make this work, to actually get it into a surgery, to make it actually work in a surgery, you need to have a whole bunch of people who come on side. There's all sorts of obvious stuff around the various stakeholders you have to train, from the nurses to the doctors to the various people, bureaucrats working around the space to get it right. But then secondly, the people you thought would have been incentivized to support this, the administration of these hospitals, actually weren't the least bit interested. And the problem there fundamentally was, actually, partially, they quite disliked the doctors. And so, therefore, the idea they're going to make life better for the doctors was not something that particularly appealed to them. And they passed this across to the IT department, because if you're trying to put this into the complicated mix of existing spaghetti infrastructure and IT in a medical situation, you have to get it through IT. And IT will go, yeah, we really get this, this is really important, it's really high on our list, we'll get to it in 3 years' time. And in 3 years' time, obviously, other things will have passed over, the incentives got to a different place. So you get to a place, you've built something quite cool, but all the incentives don't align to make it right. On the right-hand side, by contrast, this really simple, pretty basic thing you put out there. The incentive at the end of the day was partly for the people making the calls, that they were not happy to be tracked. But the real issue was their customers. And their customers were the people who were fundamentally getting the leads they were generating. And they were people who mostly didn't care that much, as long as they could sell something. But every couple of years, a federal agency would come along and do a deep dive look into what's going on. And if you got it wrong, you went to prison or you got paid a massive fine. So the incentives there were suddenly very happily aligned, because you could see people going, this is something that really will make my life different. And if I can get this right, it'll protect me. Now, it may not protect me entirely from every single missed call or missed sale, but it gives me a level of protection when the feds come calling that will put me in a totally different place. And so really understanding the context in which you're rolling projects out and the incentives to make them work is really critical, because if the incentive is there, it will happen, it'll work. If the incentive isn't there and IT get involved, it really won't happen and it won't work. So I think just one of the broader points here, sorry, this is slightly weird imaging now, but what we try to do is we think about the shift now for chief executive's perspective as we move from sort of what we call predictive traditional AI to the new wave of generative AI we're seeing everywhere. And AI has effectively gone from almost being too hard, which is most of our projects would end up with a punchline, which is, look, go away and sort out your data pipelines. Competitive advantage does not come from doing AI, it comes from being in a position to do AI. If your data pipelines and so on in the right sort of place, then you can do AI, then you can play, but you need to go away and spend the time and the money to get to the right sort of place. The problem now is that chief executives think with generative AI, they could just hand this out to their teams and it goes fine. So we're on a call today with a team who said, yeah, what we want to do is train all our staff to use AI, it's going to be brilliant. And they'll come up with all the great use cases, and all the stuff will come up through the floor, let 1,000 flowers bloom, and in the right sort of place. And the problem, again, you get back to this, which is the incentives are now all in all sorts of funny places. And so we need to really think through how we get those incentives in the right direction. So just to end on some thoughts, what we've observed in terms of trying to make these projects happen, because AI fundamentally, as all the people have talked about, is about making quite significant change inside organizations, about making quite significant change in how things work. So what do you need to do to make change happen? First, you need to create a burning platform. Now, you may not be, your industry is about to go bankrupt like the newspaper industry was, but you do need to have a very clear reason as to why the world needs to change. What is it that's fundamentally going to drive a change and get things to a different place? People need to feel they need to act. And secondly, it can't just be, we're all doomed, we're all doomed. There's got to be a vision. There's got to be a sense of where you're going to. What is it that this tool is going to do? What is this that AI deployment is going to do to fundamentally move you and your organization to a better, to a happier place? And it's going to be done with a clear, realistic plan. And typically, you need to keep the CFO on board, because if the CFO is on board, the rest will follow. So you need a clear plan with financial incentives, ROI, and all those things laid out. One of the challenges at the moment with generative AI is articulating the ROI case. We're getting closer to it. A lot of it's about 25% productivity. What does that really mean? Does that mean 25% less jobs? Does that mean people doing 25% more? Articulating these cases is really important and a key part of the work that we're doing at the moment. Fourth, any change program, you have to bank and celebrate the small wins. It might be a tiny win. It might be literally someone wrote their report twice as fast as they normally do. But those need to be really picked up and sold and shot across the piece. Everyone is aware that that traction, that momentum is there and is driving things forward. Build a center of expertise, and expertise clearly has to involve AI experts, deeply technical people, but also it has to involve actually the domain subject experts. You need people who really know how that process is going to work, what the decisions are that are taken inside the medical, the medical facility when people are cutting people up, really understanding that stuff in detail. And then fundamentally, you need the sort of translators who can articulate the conversation between those two sets of stakeholders. How is this AI going to actually impact on the human side of things as well? You need to mobilize the clear set of stakeholders across the broader business, because if you get those various people mapped out, you understand what drives their incentives, that is how you can potentially make change happen. That is how you can keep people focused. Education is your friend. I just cannot emphasize enough. I'm sure you're all aware of this. Everyone thinks they have to know about AI now. They're all at Davos last week talking about AI at great detail at the World Economic Forum. A high proportion of what they're talking about was effectively nonsense. But the point is, people feel they need to talk about this. And therefore, what needs to happen here is education process needs to continue. We need to be really helping people understand what goes on here. We cannot undereducate in terms of reassuring people, also giving people a real sense of what the future looks like. And that comes to my final point, which is you can never over-communicate. When you're making a change, when people are scared about their jobs, when they're scared about the impact of what this means, you can never over-communicate that change to make things happen. If you get all those things right, you have a small chance of taking your 80% failure rate on projects to maybe a 50% failure rate, which at this stage is quite a good thing to go for. Thank you.
Thank you very much. So if everybody would come and rejoin us, and we'll just go to questions from the audience if we have a microphone ready to go. So thank you very much for those points and presentations. Does anybody in the audience, if you wouldn't mind waiting for a mic, just so people who are watching online can hear. If anybody has a question, they stick their hand up. So Oliver, I can see your name. So
hello, great. No, I wrote it big enough.
Yeah, well done.
Hi, thanks everyone for your presentations. Really, really interesting. I have a question really for all of you, but maybe more for you, Alex, on your point around explainability. One of the barriers I see to widespread adoption of AI, but specifically generative AI, is I feel that organizations open themselves up to a lot of risk, in the sense that my understanding of large language models, for example, is that it's very difficult to work out the provenance of where the data's come from for any output. So explainability is a real challenge. I think we've seen the example of the New York Times. They're currently facing litigation, or they're suing OpenAI for this very issue. So how do you overcome this issue? I think you could argue that small businesses like some of the startups in this room are never going to face litigation of that scale, but I think litigation can be crippling for any business. So how do you overcome this issue of explainability, and how do you shut down the risk of litigation and so on?
Yeah, very good question. The explainability of kind of any kind of ML and AI system is inherently very challenging, in that, in effect, whether it's large or small, the model has been trained on vast amounts of data, and the rules that make AI so powerful for solving business problems are incredibly hard for people to interpret directly. So the very best explanation for any AI output would be just to send a printout of the weights of the model, which obviously isn't going to work. And so it's about how do we get to the right level of abstraction that people are comfortable with and can sort of rely upon. And whilst we've done a lot of research and built and implemented a lot of cutting edge research and our own research at Selden, and I think what we found is, even given the sort of the kind of raw tools to embed explanations within their data, their ML pipelines, organizations are quite far behind still, where they expect to be, similar to the kind of, the overall deployment of models. So I'm sure it will get there over the next few years, and I think the increasing pressure of regulation will force companies both to build the kind of data science capabilities in-house to embed explainability, and also for vendors like us and others to build better tools that can abstract away some of those complexities further. But it's still a very challenging problem, and certain elements of, say, LLM explainability are a very open research question right now. So a lot of it is very subjective.
Thank you, Alex. Nick? Yeah, sure.
So I think that there are several use cases that involve a sort of public-facing large language model thing, or you put it on your customer service thing, and then you're very much open to these types of problems. But I think there are a huge number of use cases where we're going to have the LLMs working much more behind the scenes with a human in the loop, and then those risks aren't quite so prevalent. But information traceability, I think, is a key thing here. We need to know the provenance of the information. We need to have citations, ideally, for every important piece of information. I think that's where we're going. The tech to bring in relevant sources and cite relevant sources, as you would expect, in any sort of reputable source or academic literature. That's how it's done. Information is given a citation. I think that's sort of a short-term practical thing that models are going to need to be able to do.
I would also add into that, obviously explainability is very hard, but testing what you're doing is very important, making sure that you have a good handle on how you feel your model is performing with real data. And then also, like you said, if you've got a risky scenario, like Nick just said, human-in-the-loop systems are the way that people are going right now to make sure that the AI system is helping somebody do their job and not doing it for them in a risky scenario.
So I think it's key to think about different ways of thinking about explainability. There's clearly a way to think sort of the way Alex talked about in terms of what the algorithm's doing and how it's working. We produced some of the first AI explainability statements in line with the ICO under GDPR. And under GDPR, you're expected to explain when you make sort of human-based decisions. So there'll be court cases in Holland and Italy around, for example, workers have been fired because the algorithm made a decision and they've basically been able to go back and sue under GDPR. So under the AI explainability statements we produce for Healthily and Harview, which is a HR company and a medical company, what we effectively did was we articulated very clearly the processes they've gone through to build their product. So what's the reason why they're using AI, where did their data come from, how their data is trained, the impact of the data, so also the whole sort of governance process around making sure that they're checking for ethical bias, they're making sure all those various issues are being worked through. So what you find is that the process of going through and building those statements, which are quite complex, they take a while because you've got to interview a whole bunch of people and get there, you begin to unearth also internally some of those questions they've not really answered yet about how do we handle certain issues around bias and so on. So I think, we're not there yet, but with the AI Act coming through in Europe, which I suspect most companies in this country end up aligning with broadly because they want to access the European market, the need to have that transparency around how you made decisions, why you made decisions, provenance and so on, are all going to become actually just a natural requirement.
Just a quick one on the AI Act. My understanding is that applies to all businesses or who want to trade into Europe. So that would apply to the UK as well, just to confirm?
Well, the AI Act will not apply to the UK, but if you're looking for a large-scale market at some scale, at some stage you'll need to operate in Europe. And my understanding is if you're dealing with EU citizens, then it'll be something you could end up being sued on. I also strongly suspect that looking around the world, other countries are going to start following the EU AI Act because it's got that sort of gravity well feel in the way the GDPRs end up being effectively implemented very similarly in California.
Thank you.
Gentleman over there.
Hi, I'm Sasha from Canopy.security. So great talks, thank you very much. On the one hand, there is all the myths that there are about AI, like it's going to steal our jobs. It's because all of that is influenced by sci-fi, and then maybe some of the leaders in that field, OpenAI and so on, kind of play on that note to kind of fascinate people with AI. On the other hand, in today's talks and meetings, and what you showed, there are some very valuable use cases. There is all the practicalities, the data, and so on. Now, my question is, what would you tell the world, like Davos or whatever, that would democratize AI in other ways than telling people stories? What's the one thing that you would tell people in terms of this is not sci-fi, it's actually concrete?
Well, I think one of the important points is that there are lots of boring problems that people do solve manually, and they would probably prefer to live in a world where they could have all of the benefits of having a job but not have the pains of that particular one. And I think that's something that is really key. And got my next point. Who wants to jump in?
I had my opening slide a picture of a robot, and I put that up usually because I want to rant about it. Because I think one of the worst things is we envision AI as being a robotic figure, and you've got this sort of image of the sort of, the human touching their finger to the robot, and the world is taking off. But actually, this is one of the worst ways to think about AI, because AI is not a robot. AI is basically a spreadsheet with ambition. And we need to get people thinking through how this is a very narrow tool that does one thing, usually in a very brittle and quite fragile way. And it's not a sort of thing that's going to replace human beings. Because thinking about it as a robot, you think it's going to replace a human. It's not. It's going to do roles better. It's not going to do jobs better. And so people need to think through how those sort of roles and those spreadsheets are going to work in our lives, as opposed to robots are going to come take over the world.
Any further comments on that?
Yeah. Same, I was going to say, I've talked about AI as being, number crunching before. Maybe spreadsheet is another way of thinking about it. We're just doing computations under the hood, and I think people put a lot of their own thoughts and ideas from sci-fi into that. So I think cutting through that and explaining to people that it is computing in the way that we understand it, and it is to do with number crunching, and it doesn't sound very exciting, and I think that puts people off sometimes when you try and explain what it is under the hood. But the other thing I think also is under here is education, because, like you said, there's an awful lot of hype about AI in the world right now, and I think if you don't know what AI is, it can be really difficult to figure out what you should trust and what you shouldn't trust, and what's right and what's wrong. So I think it's up to all of us to help sort of demystify what AI is and what it can do and what its strengths and limitations are, in order to help people understand, how they can use it.
Thank you.
Gentleman at the back there.
Thank you all again for your talks. Fantastic. My question's about judging the performance of these systems, both on their own, but also when they're embedded in a bigger system that has people in it. It's been touched on a bit before by you already, but I'm interested in more of your thoughts on it. That how do you come up with a number about how well the system's doing, and how can you break that down into finer grained numbers so that you can see that the system is performing well in some situations but less well in other situations, and how that has implications for things like fairness. If the greater system is making decisions about whether someone gets a loan or not, is the system taking into account someone's ethnicity, either directly or indirectly? So how do you judge the performance of a system? How do you break that down into a finer grained way? And how does bias get into that?
Who wants to go on that?
I'll kick off. So yeah, it's a very good question. And as organizations go from managing a handful of models to tens or hundreds of models, this becomes a incredibly hard problem. And a lot of this is one of the reasons that a lot of organizations are moving from having kind of disparate data science teams that are very kind of autonomous in their way they can operate and manage their things like their model catalogs to a more central AI platform team, so they can monitor more effectively all the various use cases and the full ROI of each of these initiatives. There's one part of it is the just kind of core operational monitoring, so just the effectively amount of compute and cost associated with each of the models, and then there's a fair amount of kind of data science based monitoring, so things like monitoring for accuracy, drift, and outliers, for example. And a lot of the cost that organizations bear in general is when systems are reporting false positives or false negatives, and then they have to act upon those. So where you can, in effect, analyze the impact, the cost of those. Let's say, it was a classic case many years ago, speaking to one of the fraud detection leads or the anti-fraud people at a very large bank. They said, yeah, we could resolve fraud overnight. We'd just have to we'd have to investigate every single transaction, and obviously that's not going to be viable. So it's that kind of finding the right balance and having the tools in place that they can sort of target their investment, or frankly which projects to cut as well.
Yeah, and the main question is, what do you measure, I think, at the core, and what does that mean? Because you've got benchmarks, you've got accuracy and precision and recall, and all of these things, if you actually drill down into it, the answer really is complicated. What does that mean? And what does it mean for my specific use case or my specific experience? And it's one of the big problems in the field. You have people putting out models and claiming that they're better than GPT X, but on the basis that their numbers are higher on these various metrics, and it's an unsolved problem.
Yeah, I think you've made some very good points in all of this, and there's lots of different ways to measure the performance and monitor how machine learning systems are doing. So things like accuracy and memory usage and speed, and a lot of those sorts of things come into those real hard metrics that you're trying to use. And then you have to link them up with some of the business metrics that you're trying to use. So if you are in a customer service application, for example, where a lot of voice technology is used, then you're looking at call center success rates and how successful people's calls are into that center, because that's what your end customers care about in the end. So there's a huge number of choices you have in how you evaluate these systems, and it's only getting more complicated as we are building these language models, which are multi-purpose and not built for one specific thing. And it's a huge research question right now. There's a lot of work going in academia to come up with new benchmarks, with new ideas, with new ways of trying to test these models. because you have to come up with a test which is new and novel enough that you're fairly confident hasn't existed on the internet yet, so there's no chance of the model already knowing about this. Maybe people are looking at, to evaluate language models, sort of multi-step questions where you have to go and look up multiple pieces of information and put them together in a sensible way in order to see if it will solve that particular question. There's a benchmark that was recently released from Facebook, I think from Meta, where they did that with these multi-step questions. And I think a lot of these are being trialed right now. There are other, in the voice world, for example, if you're trying to judge how natural a synthetic voice is, or how realistic it is, or how much it sounds like somebody, these are all highly subjective measures, and people are more or less expert in judging these things. So you've also got human judgments on the performance of a system to take in there as well. So if you can answer it, I think you've got a brilliant career ahead of you.
So a couple of thoughts. I mean, first, I think in the broader management sphere, there is actually a real shortage of just understanding the language around this sort of stuff. If you think back to sort of politicians discussing fake negatives and so on in the course of the COVID crisis, you get some sense of actually all the people who've been trained like me as medieval historians have often very little idea how to talk about statistics. And I think part of the challenge is how we educate more widely some of those people making decisions. Second thing is, I think with some of the clients we worked, for example, they've actually built sort of ways of taking the data, taking their models away and actually just testing them in real world scenarios. So the example where we work with people who do sort of voice stuff for around HR and job applications, they basically check that against a mix of people with different voices, different ethnicities, different accents and so on, to try and understand what works, what doesn't work, and try to make sure that the models they're building are basically end up being as strong as possible. And they will then go through and take out certain questions, for example, that tend to have negative correlations against certain specific ethnic groups, for example. But I think the thing that's interesting there is that they're doing that against job interviews. Humans, when they do job interviews, are full of wild biases and crazy ways of doing things. And one of the, I think the great unsold opportunities of AI is the chance for us to look at our own world and hold a mirror to it and work out how we can be better. So the organizations that, for example, you know, the one prime example, great examples of AI not working very well is an Amazon recruitment algorithm that basically ended up sort of being turned out that if you were a white or a East Asian man who'd been an engineer, you know, you tended to do far better than women or African Americans when you applied to be an engineer at the firm. Now, clearly, that was based on historical legacy decisions that gone into the training data and ended up creating an algorithm that, whatever they did with it, however they tried to reweight it and so on, kept on delivering results that were, frankly, in effect, you know, unacceptable. And so what it effectively, to my mind, says is that's a mirror to the world in terms of saying it's not the algorithm that's the issue, it's what's going on in your management decision making, what's going on in your processes. And that to me is one of the big unsold opportunities of AI. You're taking this data, you're putting it into a machine, and you can't say at the end, oh, there are some bad apples, we made a few bad choices. There's clear mathematical evidence, you've been making bad choices for inappropriate reasons, go and do something about it.
So thank you very much to the panel. That was a fantastic set of questions and a good place to end this conversation. I'll just end with a plug. We put out a newsletter. You can see the URL up on the slide. If you want to keep up with the news, we do a weekly digest of what's going on in this space. In the meantime, thanks very much for everybody who's come online and in person to this session in Cambridge. And we'll be having some drinks in the area outside, and there'll be a chance, I hope, to ask our panelists some more questions. So thank you very much again, and good night.